Hello everyone, welcome to Shorov's classes. Hope you all are fit and fine and doing well in your studies and mathematics. So today we are back with another session of tomato problem solving, objective part. And again I want to say that those who have seen the previous videos are very well, but those who are new to this, tomato stands for this book, Test of Mathematics at 10+2 level, which is published by Indian Statistical Institute, East-West Press. So this video is meant for aspirants of Indian Statistical Institute and Chennai Mathematical Institute, and for aspirants like these, people must have, so this book is a must for people to have, Test of Mathematics. And since this book is published by I.S.I, so the authorized signatory body who is taking the examination, so we have decided to take up problems from this books. This book's problems, thousands of problems including MCQs, and we can get also subjective problems here, including MCQs and the subjective problems that will enhance the problem solving ability. And I.S.I people who set the question papers, the teachers want you to be familiar with these kinds of questions. This is because you will have to experience or encounter such types of problems in the actual exam of I.S.I and CMI. So I.S.I exam contains two parts, and even this book contains two parts. The part 1 is objective and part 2 is subjective. So we are dealing with objective problem solving in I.S.I. So we are headed with the first question. So the first question as written in the board is, find the number of rational roots of the equation 3x squared plus 5x plus 7 equals to 0 equals to is 0, 1, 2 or none of the above. So I give you a few moments time to solve this and try and attempt this before I get to the original solution. So this is the question portrayed in front of you. Okay, so the time that was meant to be given for this problem is over, and I hope that everyone, if you have tried this problem, because I always say that trying a problem is very important than always solving it. So you need to solve problems in exam, but for practice, first of all you need to try a problem. Trying a problem increases emphasis, gains your mathematical interests, and have a thrust on the mathematical aptitude. So for this problem, I'll give you an important concept. So concept concept of rational roots when A, B, C are integers. So here we will deal with rational roots where in the equation ax square plus bx plus c, A, B, C are integers. So what can be the conditions for or the concepts for gaining a rational root? Now there might be many possibilities. So first we consider the possibility that since they are integers, so all A, B and C are odd. So odd numbers means numbers of the form 2k plus 1. So A, B, C belongs to 2 times n plus 1. It means that these are all odd numbers. Now my question is, does a rational root exist when all are odd numbers? So we are dealing with odd numbers now. So the question is, does a rational root of this equation exist when all are odd numbers? So let's see. So let the rational root be P by Q, okay, where P is both P and Q cannot be even. Why? This is because we know that GCD of PQ is 1 in case of rational numbers, that is by definition. So both P and Q cannot be even. This is because 2 is the common prime then. Okay. So what I do is that, what are the possibilities? The possibilities are P even, Q odd, P odd, Q even, P odd, Q odd. Now 0 is an even number, we all know it. So what if I substitute P by Q? So if I P by Q in the first case, it becomes AP square plus BP plus, so if I multiply by Q square, so BPQ plus CQ square equals to 0. Now this is even, but this is odd. So even plus even is even, and even plus odd is odd, and it implies that odd equals to 0, which cannot happen. Now again, if I substitute, I'll get the same thing. So again, so this is odd, this is even, and this is even. So even plus even is even, and even plus odd is odd, and odd equals to 0 cannot happen. And the last case says both are odd. So odd, this is odd number, this is an odd number. Odd plus odd gives an even number, and even number plus an odd number again gives an odd number, and odd number cannot be 0. So we see that if A, B, C cannot, if they are all odd numbers, then there does not exist any rational roots, and the proof is this. So we see that if A, B, C are odd integers, this is the main practical concept of finding rational roots, that if A, B, C are odd integers, there cannot be any rational root. So this is the most exploited theorem, I must say. Now I'll use this theorem to solve the problem. So there does not exist any rational root. So for existence of rational root, at least one of and of course I forgot to mention GCD of A, B, C not equal to 2. So for ax square plus bx plus c equals to 0, a, b, c belongs to odd numbers, and GCD of a, b, c not equals to 2, there does not exist any rational roots, which implies that if rational roots exist, at least one of a, b, c must be even. Now what was the question that we are dealing with? So I know many of you have computed the roots and you have checked that that is not rational. But now, after using this theorem, you will be able to solve a bunch of problems like these just in one line using this concept. So the equation that I give is 3x square plus 5x plus 7 equals to 0. Now GCD of 3, 5, 7 not equals to 2, and 3 is odd, 5 is odd, 7 is odd, so odd, odd, odd. I am denoting the odd by O's, therefore no rational roots. Answer. So this is the answer, that therefore no rational roots. So you see that you can solve a bunch of these problems in competitive exams that appear in MCQs of I.S.I and CMI easily by using this particular theorem. Okay? So just keep in mind that this is a very important theorem that is to be stated. So just for an example, I will give you a problem from an I.S.I paper that directly came as a question. So just imagine that this theorem directly came as a question. What is the condition on, sorry, so the options are at least one of A, B, C is even. All are even. All are odd. None of the above. So this is a direct question regarding this fact of the theorem. So I hope that by you knowing the theorem in the previous context, you are already being able to solve this I.S.I problem very easily by yourself, and you can do without touching pen and paper. Option A is the correct answer. So this came as an I.S.I problem, and that's why I just taught you that theorem, because that theorem is very important not only for I.S.I but also for CMI and other Olympiad types examination or Olympiad type stuffs. So let's get back to the next problem, of the third problem of the day. So we will get back to the third problem of the day. Okay, so this is the third problem of the day. It says that if the roots of the equation x minus a x minus b plus x minus b times x minus c plus x minus c times x minus a equals to 0 are equal, then, sorry, that would be the, so this is a grammatical mistake. So then the what is true? So which of the relations is true? So option A, b square minus 4 is equals to 0, option B, a equals to b equals to 3, option C, a plus b plus c equals to 0, and option D, none. So I give you some time to just try out this question before I get into the solution on my own. I got a comment. Okay, so the time meant for this question is over, and before solving this question I want to get into the important concept as per the way I solve problems. So the concept is here that is to be taught is intermediate value theorem. So this is a very important concept. So I have just giving it a, I must give a much more time stick, but that will sound impractical. So intermediate value theorem is a very, how many, as much varies as you like, you can add from my part. So it says that if Px is a continuous function, such that PA greater than 0, PB less than 0, then there exists C such that PC equals to 0, where C is between A and B. So it says that if Px be a continuous function such that Pa greater than 0 and Pb greater than 0, then there exists a C in this interval such that P of C, Pc is greater than 0. Now you don't know, it might sound trivial to you at the first attempt, but you don't know that how wonderful this concept can be. Let me show you with the example problem that I have chosen. Now suppose Px here given is into x minus a. So suppose that these have equal roots, but a not equal to b, b not equal to c, and a not equal to c. So suppose it has happened, suppose. Now then a greater than b greater than c, or it might happen that one of them is largest. So without loss of generality I assume that this has happened. Okay, so P of A, what is P of A? 0, 0 is A minus B into A minus C. So A minus B is positive, A minus C is positive, hence this is positive. Now P of B, this is negative because B minus A is negative but B minus C is positive. P of C is again positive. So by intermediate value theorem, between this A and B lies a root, and this between this there is a root. So root 1 and root 2. But you can see that root 1 can never be equal to root 2. This is because they both lie in entirely different intervals. And therefore A greater than B greater than C is absurd, so it's a contradiction. Isn't it? So let me repeat that if I assume without loss of generality A greater than B greater than C, then P of A is positive, P of B is negative, P of C is positive. By intermediate value theorem there is a root 1 in A and B, and by intermediate value theorem is root 2 in A and B, but these roots can never be equal. This is because if these are equal, then they must lie at the same interval, but here I have assumed that A greater than B greater than C, therefore no two are equal. So for this equation to have equal roots, the necessary condition is A equals to B equals to C. Answer. So according to Test of Mathematics book, the correct is option B. So we see that we have learned another important concept in this session. So this is one of the very important concepts that we have utilized. So just keep it and remember it in mind. So without much further ado, we will get on to the last problem of this session. So just we will get to the last problem. So question, if so this is a problem which utilizes the previous concept that I have taught. So after learning a concept, it is essential to practice a problem on that particular concept. So I give you some time to try this out before I get directly into the solution part. Okay, so the stipulated time meant for this problem is over. And now we will get on to the solution. So as I said that this solution requires keen observation and the previous concept. So a plus b plus c equal to 0, greater than 0. A minus b. Now I want you to focus on this quadratic equation and these expression. So do you find any similarity between this quadratic equation and this expression? Do you? Of course, the quadratic equation coefficients properties are given here. But how can the coefficients properties be related to these effects? If we think a bit, we will observe that this f of a plus b plus c is nothing but f of 1. But a plus b plus c is greater than 0. Now if I place minus 1, but this is given to be greater than 0. Now if I place 0, so how does it come? So f of 1 is greater than 0, f of 0 is less than 0, f of minus 1 is greater than. So by the intermediate value trick that I taught you, in here lies root 1 and here lies root 2 by intermediate value trick, and therefore the number of real roots is 2 in this interval. Okay, so this is the last problem for the session. So in this problem solving session, we have came across very interesting problems with many new concepts. We have came across many new ideas on how to solve problems, many new stratagems, many new theories. So I said that please don't restrict yourself to this video. Go sit with pen and paper, practice problems. Practicing problems will make you perfect in the examinations. For more tricks like this, so you just can't use the tomato book only. So you need other resources for problems, for theories, for learning these tricks that I am displaying on the board. And for those, Saurav Sir's classes publishes high quality study materials for I.S.I, CMI, Olympiads. So you must get a copy of your own and see it, practice those problems thoroughly, and they will definitely bring you a good result in the examination. So all the best for your upcoming tests. Bye bye and stay tuned till the next part.